Hello, hello, hello everybody, and welcome back. We're looking at question 8 in this video on our 2010 Euclid paper. So 8a, Euclid. I've never seen that name before. It doesn't look like a pun or anyone's name who makes up the contest or anything like that. I guess it's just an interesting name. Euclid tosses 3 fair coins and removes all of the coins that come up heads. George then tosses the coins that remain. Okay, so if Euclid tosses all heads, George doesn't toss a thing. If Euclid tosses 2 heads and a tail, George tosses 1 coin because of that tail. The other 2 heads got removed. Determine the probability that George tosses exactly 1 head. So what we've got here is a sequence of events, and the best thing to sort of analyze this situation is probably going to be a probability tree. So let's talk about what can happen. So Euclid tosses his coins. So we might say O or first toss, probably make things a little clearer. And we are trying to write things up. So first toss, we could have 3 heads. Euclid could get 2 heads and 1 tail. 1 head and 2 tails, or finally no heads and 3 tails. And depending on this toss, George has a certain number of coins to work with. So 0 coins for George, 1 coin, 2 coins for him to toss, and 3 coins. Okay. Now, we're not done with this first toss because we have to figure out the probabilities, because the chance of getting all 3 heads is different than the chance of getting 1 head and 2 tails. And you can see that by listing out the possibilities. I could have all 3 heads. I could have the first 2 heads and then the next one tails. I could have the first and third heads. That's a way to get 2 heads and the middle one be tails. So these are nice possibilities. We also have tails, tails, tails. Tails, heads, tails. Tails, tails, heads. I haven't adhered to my usual principle of find a good way to write them all out in an orderly fashion so you know you don't miss any. But with 2 options for each coin flip, and the coin flip's happening 3 times, that's going to be 2 times 2 times 2, 8 possibilities, and I do have all 8 possibilities. Okay, so by examining our 8 possible outcomes, we can assign probabilities to the first branch, or the branches. Okay, so we'll do that, and then we'll analyze each little George subcase. But the important thing to remember about probability trees, and they're not a very big focus in high school. They can pop up in certain data management things. But the important thing to remember is we're going to have our first toss, and then we're going to have the outcomes of the second tosses. And they're going to have probabilities like a half and a third or a sixth, things like that. And for our 3 heads, for example, only 1 out of our 8 possibilities was 3 heads. So there's a 1/8 chance that we'll be up here, and then a half a chance that we get a single head or something like that. The probability of getting that single head by traveling along these branches is 1/8 times 1/2, 1/16. And it's important to remember probabilities along branches multiply. Okay? Just in case you're not the most familiar with probability trees. There usually aren't a whole lot of probability questions on the contest. I think a couple more have been creeping in lately. So it is a useful thing to know. I'm also going to draw my tree a little better. Not that this is the last time I'm going to be drawing this tree, but here we go. 3 heads, 2 heads, 1 head, 0 heads. Oops. Okay, so 0 heads is the same as 3 tails. There was only 1 out of 8 chances of that happening. 3 out of 8 for each of these middle ones, and 1/8 of a chance of getting 3 heads. So in the first instance here, the 3 heads, that means George has 0 coins. So I'd probably just say something like 0 chance of 1 head. So first toss, second toss. Now for the two heads cases, one coin is left. So that is either a head or a tail. That happens with probability 1/2 in each outcome. So we can have, I'll fill this in as well, 0 tails, just so I'm a little consistent. So the outcome we're interested in having happen is have two heads flip up, the remaining tail is kept, the other two coins are discarded. That coin is flipped by George, then the head flips up, that's 1/2, so 3/8 times 1/2. 3/16 of the time, George will get a head from this particular path. There will be other ways to get heads. For example, now here with two tails, there's two coins for him to flip, which we noted on our previous page, and you can definitely refer back to that diagram. Let's say 0 heads, 1 tail. I'm just trying to include the number of tails as well, just so it's very clear to whoever's marking that I know how to make these trees and I understand what everything means. And it does look like I'm going to run out of space. We might cram it in there. Okay, now, once again here, we're interested in, so we're down here, but we're only interested in the outcome for this branch. Now I'm going to fill everything in, and I can do it by making the same little list of possible outcomes. So 1/4 of the time, 1 out of every 4 times, you'll get the two heads. 1 out of every 4 times, you'll get the two tails. And then there are 2 outcomes left that have both a head and a tail in them. We don't care about the order. So again, 1/2, and again, the probability is going to be 3/16, because it's 3/8 times 1/2. So in our final case, which I'm going to write onto the next page, you would include in the big probability tree. So we'll just pretend we were coming from there. So we had 0 heads and 3 tails, so all 3 coins were left to George. So we once again have 3 outcomes, 3 heads, 0 tails, 2 heads, 1 tail. Now you could probably prune the tree a little bit by just figuring out the probability you want, but unless you can make a convincing argument with, say, binomial coefficients or something like that, I would just write out the big tree. It makes it very clear. And we don't really have to do any extra work here because these are probabilities we already figured out for the first tree. So how about that? We saved some work. Okay. Once again, what are we interested in? Well, Euclid did his toss. 3 coins were left for George, but we're interested in George getting just 1 head out of this. So that's 1/8 times 3/8. That's 3/64. So the probability George gets 1 head, no matter how he does the tosses, is, so we had 3/16, another 3/16, and now 3/64. Multiplying by 4, you'll get 12 plus 12 plus 3 all over 64. And that will be 27/64. I think we had, what was it, question 5? Question 5 or 6 had 64/27 as a solution. So that's kind of cool. Just a little observation. Okay, so that was a part. We have explained things. We've got a tree. You don't have to explain to people how probability trees work unless you set yours up different than how people typically do. Okay, that's 8 there. All right, so 8A is done. How about 8B? In the diagram, points B, P, Q. Whoa, what's going on here? I swear the programs I use are so old. Anyway, okay, in the diagram, points B, P, Q, and C lie on the line segment AD. Okay, great. This looks like a very confusing little picture here. The semicircle with AC has center P. And the semicircle with diameter BD has center Q. The two semicircles intersect at R. It looks like we've also got a nice little triangle going on here. If PRQ is 40, determine the measure of ARD. At full angle there. Okay. So we want ARD. Let's draw our picture pretty big. Oh wait, no, it's not one single semicircle. It's a couple semicircles, isn't it? So big line, semicircle, semicircle. So there's your R. We'll say Q is there. P is there. We don't actually need A and D. We just need, what are they? So B, D, C. There's A. Okay. Okay, so I'm going to try and color code this to make things as simple as I can make them. So orange angle up here is 40 degrees. Fine. And then we want the big one, ARD. Now the PQ is sitting in there right in the middle, so I am really tempted to say, well, let's let this be X and this be Y and see if we can figure something out. Now the pictures and the lines are getting quite involved, but definitely going to start off by saying, let ARP be X and DRQ be Y. Now I think, well, let's just look at, so by breaking it down into A, P, and R, that's all just on one semicircle. I don't know if this is oversimplifying things, that we might for some reason need that other semicircle there, but R is somewhere up here, P is the origin, or not the origin, the center. And so we want just sort of this angle here. I don't quite know what this angle up here is, but I do know RP is equal to AP as both our radii. So that would make this an isosceles triangle. So PAR is isosceles. So angle RAP is X. Similarly, you can write the whole argument out again, but I think just another picture will do the trick. Q, D, and R is somewhere up here. Similarly, RQ equals RD, and angle RDQ is equal to Y. Okay, it's the exact same argument, so why bother writing out as much? Just say similarly and then highlight the main points. It saves you just a little bit of time, but that's more time to devote to questions 9 and 10. All right, putting them back in the big picture. I think that completes our triangle. Now I'll just draw the main triangle there. So we've got A, R, D, and then we've got, I guess, P here. And Q down here, I guess. But we have X, 40, Y, and Y. Since ARD gives a triangle, we see that 180 degrees is 40 plus 40 degrees plus 2x plus 2y. So 140 degrees is 2x plus 2y. 70 degrees is going to be x plus y. Now that is not, I cannot figure out x and y individually, but I don't need to, because ARD, which is what we were asked to show, is 40 plus x plus y. So that is 110 degrees. And there we go, all taken care of. So we had to look at the pictures together, get some names for sort of these angles, realize that they were of interest, break it up into two semicircles and use circle properties, and then combine them back together. I think that was sort of a neat little give and take question there. And hopefully question number 9 will be just as neat. I will let you guys try that out for yourselves. I will be taking that up in the next video, but see what you can make of it before watching. As always, have a wonderful day and take care.